Okay, now we move to partitioning based clustering. Okay, most important type of clustering, partitioning based clustering. In partitioning based clustering, we partition the data set of an object into number of clusters, let's k clusters or groups, such that the sum of the squared distance is minimized. Okay, the sum of the square distance is minimized. That means suppose a cluster and some points are there. Okay, then the mean point or centroid, mean point is called centroid, let's see, centroid, then the distance between this point and centroid of the cluster is minimum. So the total sum of distance between points and the mean point is minimum within a cluster. So points within a cluster are too close to the centroid or too close to each other. Okay, and the another importance is when we partition the data object into number of clusters, then these clusters are disjoint. That means no point occur in no common point in these clusters. So clusters are totally disjoint. Okay, and that is a partitioning based clustering approach. Okay, now formula for the finding the square distance is E equal to summation I equal to 1 to k summation p belong to ci, then pi minus ci bar whole square, where ci bar is called centroid or medoid of the cluster ci. What is pi? Pi is an object in the cluster ci. So what is k? K means number of cluster. So I explain what is pi. Suppose pi is this point, and what is ci bar? Ci bar is the centroid of the this cluster. Suppose this cluster is called I. Okay, and this cluster is j. Okay, so centroid of cluster j is this, and the point o or p belong to this j cluster is this, and the distance between this point P to the centroid Cj bar is calculated by Pi minus C I or J जो भी आप कह सकते हैं J bar का whole square. Okay, now P belong to Ci, that means P is a point belong to Ci or Cj. Okay, and the distance between Pi and centroid is minimum. Okay, and here k is the number of cluster. Okay, we already discussed k means, k medoid, are some examples of partitioning based clustering. Now we discuss here k means clustering algorithm. K-means clustering algorithm is very important type of partitioning based clustering algorithm, which widely used in many applications. Okay, K-means algorithm is a centroid based clustering algorithm, and it is also a partitioning based algorithm. I already said. In K-means clustering algorithm, it divides an object into k number of cluster, and with the help of distance measures such as Euclidean distance, Manhattan, cosine similarity, and so on. Before proceeding with actual algorithm, let's see, I explain the algorithm with the help of an example, and when we understand the example, then we easily understand the algorithm. Let's see. Suppose we have a data set D, with a number of attributes are suppose object ID, name, heights and weights. Height in inches and weights are in kg. There are 4 tuples or 4 data objects in the dataset D. Okay, and these are x1, name is Ajay, height is 64 and weight is 60. Another object is x2, name Vijay, height is 60 and weight is 61. Then object ID is x3, name Shri, height is 59 inch and weight is 70 kg. And last object is x4 with name Mohan and height 68 and the weight is 71. And we given the number of clusters are 2, so we divide these 4 points into 2 cluster with the help of K-means algorithm. Okay, now we proceed the example as such. Okay, now we proceed the example with solution. Now in the first iteration, suppose it is an iteration 1. Okay, now what is this algorithm? We since we have to divide these 4 points into 2 clusters, so we randomly choose in 2 points. Okay, with points as centroid of the 2 clusters, suppose C1 and C2. So let these points are x1 and value of x1 suppose height is 64 and weight is 60, and second point is suppose x2 with height 60 and weight is 61. So we start the algorithm randomly choosing 2 points as centroids of the 2 cluster. Why we choose 2 points? Because we divide these 2 points into 2 clusters. These value of number of clusters are already given. Okay, now let's see, we these 2 points random chosen points are x1 and x2. Now we find the distance between all the points and these centroid. Okay, now distance between x1 and x3, here we use Euclidean distance measure. So we know that what is x3? x3 is 59, height is 59 and weight is 70. Okay, so we calculate the distance between x1 and x3 is very simply 64 minus 59 whole square. We know that the formula of Euclidean distance. Okay, plus 60 minus 70 whole square. So after calculation we got 11.18. Similarly, we find the distance between x2 and x3. This is 60 minus 59 whole square plus x2 x4 x2 x3. x2 is 60 minus 59 whole square, 61 minus 70 whole square, and we got the value 9.06. Similarly, we find the distance between x1 and x4, and which is 60 minus 64 minus 68 whole square plus 60 minus 71 whole square, and then we get a final value 11.7. And now finally we calculate the distance between x2 and x4, and which is calculated as 60 minus 68 whole square plus 60 minus 71 whole square, and we get the value 12.81. okay, and these are the distance between centroid and the other points, and we clearly see that between these two distances, x1 and x3 and x2 and x3, the nearest distance is 9.06. That means if x1 and x2 are the centroid, the distance between centroid point x1 to x3 is 11.18, and the distance between centroid point now similarly distance between the centroid point x1 and x4 is 11.7, and the distance between second centroid point x2 and x4 is 12.81, and in these two distance 11.7 is minimum, so x4 is more nearest to x1. okay, so here C1 and C2 are two clusters. So finally, after first iteration, we get x2 and x1 represent for C1, x1 represent the centroid point. So x1 and x4 are finally in the C1 cluster, and x2, which is the centroid point of the C2 cluster, the x2 and x3 are belong to the cluster C2 after first iteration. Okay. Now I explain the example with more convenient way. Suppose, okay, and we chosen x1 and x2 are the centroid of two clusters C1 and C2. Okay, initially. Now I know the other points are x1, x2, x3 and x4. x1 and x2 we choose as a centroid of our two clusters C1 and C2. Now the distance between centroid of C1 and x1 is 0, since C1 the centroid of C1 is x1, so distance between point to itself is 0. Okay, now distance between x1 to point x2 is 4.12, and distance between x1 to x3 I previously calculated 11.18, and the distance between x1 centroid point x1 to x4 is 11.7. Similarly, our second cluster is C2 and its centroid is x2. Then the distance between x2 and x1 is 4.12, and the distance between x2 to x2 is 0. Distance between x2 to x3 is 9.06, and x2 to x4 is 12.81. Okay, now clearly in this matrix, distance between x3 to x1 and x2, which is minimum? Minimum is 9.06. So x3 is closer to x2. Similarly, x4 is closer to x1. So x3 and x2 belong to the same cluster C1, and x2 and x3 belong to the same cluster C2. Here x2 is the centroid of cluster C2, and x1 and x4 belong to the cluster C1, and here x1 represent the centroid of the cluster C1. So okay, clear. Now we calculate the new centroid of cluster C1 and C2. In K means, it is called K means because it divides an object into K cluster with the help of a mean as a centroid. So in K mean, we calculate the mean value of the points within a cluster. So centroid here represent the mean value of the points within a cluster. Okay, now we calculate a new centroid or mean of cluster C1 such that x1 and x4 points are given in the example. So we easily calculate the mean value. Here 2 points, so divided by 2. So mean value of C1 cluster is 66, 65.5. Similarly, we calculate the mean value of or centroid of C2 is 59.5 and 65.5. Now we proceed to the iteration number 2, and similarly we calculate the distance between x1, x2, x3 and x4 with the centroid of C1 and C2. Now we calculate the distance between new centroid of C1 and x1 is 5.85, x2 is 7.5, x3 is 8.32 and x4 is 5.85. Similarly, we calculate the distance between centroid of C2 with x1 7.1, with x2 4.53, with x3 4.53 and x4 10.12. Now minimum between now we find the minimum distance. Let's see, between C1 and centroid of C1 and x1, and between centroid of C2 and x1 minimum is 5.85. Similarly, here minimum is 4.53, here minimum is 4.53, and here that means distance between centroid of C1 and x4 is 5.85, and distance between centroid of C2 and x4 is 10.12. Clearly 5.85 is minimum. Okay, then we finally got the cluster C1 and C2 such that x1 and x2 are closer, so belong to the cluster C1, and x2 and x3 are closer and belong to the cluster C2. So here cluster C1 belong x1 and x4, and here centroid point is 66, 65.5. Similarly, C2 belong the points x2 and x3, and centroid point is 59.5 and 65.5. And clearly, finally, we see that there is no change between the iteration number 2 and previous iteration 1 in the cluster position, clusters points. Finally we end the algorithm, because in the iteration number 2 we find the cluster C1 with the point x1 and x4, and in the like as a previous iteration in which also x1 x4 belong to the cluster C1. So and similarly x2 contain the point x2 and x3 in iteration 2 as well as in previous iteration. So finally we end the algorithm, and we got the two cluster with which divided these 4 points clearly. Okay.